So this is National 4 and National 5 Chemistry Atomic Structure. And what we are going to learn in this lesson is we're going to look at what an atom looks like and the particles that are inside it and how we can work out the number of each of those types of particle inside an atom. So the main goal is to understand the structure of. So for the first half of this lesson, your success criteria are to state the three subatomic particles inside atoms, to be able to identify a subatomic particle from its location, its mass, and its charge, to draw and label the basic structure of an atom, and finally, to be able to explain why atoms have an overall neutral charge, neutral meaning zero. So what particles are atoms made of? Now, for a very, very long time, it was believed that atoms were the smallest thing that existed in the world, that you couldn't get anything smaller than an atom. However, scientists now know that atoms are actually made of even smaller particles, which we call subatomic particles. So subatomic just means smaller than an atom. And there are three types. And those three types are called protons, neutrons, and electrons. Protons, neutrons, and electrons. So if you are struggling to remember those, you can remember the word pen, P-E-N, P for proton, E for electron, and N for neutron. Now, within an atom, protons, neutrons, and electrons are not all found in the same place. They're not evenly distributed in an atom. There are parts of an atom where you're more likely to find a proton than an electron, and so on. So this diagram on the right-hand side is a representation of an atom. And what we can see is that in the center, we have the green and the red balls, and those represent the protons and the neutrons. So at the very center of an atom, that's where you would find protons and neutrons. And the very center of an atom is called a nucleus. So similar to in biology, where the center of the cell, where all the decisions are made, is called the nucleus, the center of an atom is also called a nucleus. And what lives in the nucleus are protons and neutrons. The electrons, they go much, much further. They form the rest of the atom. And they're kind of like planets spinning around the nucleus. And the electrons can be separate from one another, but they exist within different layers called shells. So if you were to draw an atom, you would draw the nucleus as maybe a dark circle, and then you would draw rings around that circle, and those rings are the shells. And electrons are found in the shells, protons and neutrons are found in the nucleus. So with each particle, there are two important properties that you need to know. You need to know about the mass and the electrical charge of protons, of neutrons, and electrons. So we've got a table that represents that information. So here we see we've got the particles, we've got mass and charge, and we're going to look at the proton, the neutron, and the electron individually. So the proton, it's the easiest one to remember because a proton has a mass of 1 and it has a charge of +1. Now it's really important that whenever you're talking about charges that you include a sign as well as a number to represent the charge. So charge is +1 for a proton. A neutron, well, a neutron has a mass of 1, but it has 0 charge. So 0 charge for a neutron, but a mass of 1. And then we finally have an electron. An electron almost weighs nothing. So usually if we're asked for the mass of an electron, you can write 0, or you could say almost 0. that the charge of an electron is -1. Remember that if you've got a number for the charge, you need a sign as well. Now, overall, atoms contain equal numbers of protons and electrons. And that means that they have no overall charge, because every +1 charge from a proton is met with a -1 charge from an electron. So if you have 2 protons, that would give a charge of +2, but you also have 2 electrons, which would give a charge of -2. +2 minus 2 equals 0. So in order for atoms to end up neutral, having no charge, they must have the same number of protons and electrons. So now what we're going to look at is understanding the numbers of different particles within an atom. So we're going to learn what atomic number means. We are going to learn what mass number means, and we're going to be able to calculate the number of protons, neutrons, and electrons for a given atom. So the first term that we'd like you to understand is atomic number. An atomic number is the number of protons in an atom. So if an atom has an atomic number of 4, it has 4 protons. If an atom has an atomic number of 203, then it has 203 protons. It's straightforward. Whatever the atomic number is equal to the number of protons. The mass number is equal to the total of the number of protons and the number of neutrons. So the mass number tells you how many protons and neutrons combined there is in an atom. So mass number is protons plus neutrons, and remember, atomic number was just protons. Now, atoms often get described in a way that is called nuclide notation. So nuclide notation is where you have the symbol of the element and then you have 2 numbers written beside it. Sometimes there is a third number, but we're just going to start with 2 numbers. But on the left-hand side, at the bottom left-hand side, well, firstly, we've got the symbol. Then what we have is the atomic number, and the atomic number, that is what is written at the bottom left-hand side. On the top left-hand side, we have the mass number. Now remember, the atomic number equals the number of protons. The mass number equals the number of protons plus the number of neutrons. So once we have these 2 numbers, we're actually able to say a lot about this element. So we can work out the number of protons because the number of protons is equal to the atomic number. So the atomic number of aluminium is 13, so aluminium has 13 protons. We can also work out the number of neutrons. Remember that the mass number is equal to the number of protons plus the number of neutrons. We know the number of protons because it is equal to the atomic number. So all we need to do is a subtraction in order to work out the number of neutrons. So the mass number, 27, minus the atomic number, 13, which is the number of protons, gives us 14, and that's the number of neutrons. And finally, we can also work out the number of electrons. And that is because aluminium is an element, it is neutral, it has 0 charge. And we know that the number of electrons must equal the number of protons. We know that the number of protons equals the atomic number, which is 13. So the number of electrons is also 13. So for aluminium, The number of protons was 13, the number of electrons was 13, but the number of neutrons was 14. So hopefully now you're able to say what is meant by the atomic number, the number of protons in an atom. You're able to say what the mass number is, the number of protons plus the number of neutrons for an atom. And you're able to calculate the number of protons, neutrons, and electrons for an atom. What we've got now is a series of questions about the different particles. And in order to do these questions, you'll probably need a calculator, but you'll also need, for some of the later on questions, a copy of the National 5 data booklet so that you can look up some of the information about the atoms. So with these questions, the question will be put up. If you pause the video, you can then have a go at doing the questions and then unpause the video for the answers. I think there's 3 or 4 exercises for you to get through. So the first exercise is to work out the number of protons and neutrons present in these atoms. So there are 5 atoms. You've got the symbol, which you don't need to worry about for these questions. And then you have got 2 numbers. The number at the bottom of each one is the atomic number, and the number at the top, the larger number, is the mass number. So if you want to pause the video, have a go at working out the number of protons and neutrons in each of these atoms. Okay, so I'm hoping that you've unpaused the video and you have calculated the number of protons and neutrons in each of these. We'll go through the answers. So the first one, Na, is sodium, and it has 11 protons because the atomic number is 11 and the atomic number is equal to the number of protons. And then we have 12 neutrons, and that is because the number of neutrons is the mass number, 23, minus the atomic number, 11. 23 minus 11 is 12. For the next one, Fe, that's iron, it has 26 protons, because the atomic number is 26, and it has 13 neutrons, because the mass number is 56, the atomic number is 26, and the mass number minus the atomic number tells us the number of neutrons, and that is 30. For the next one, Sn is tin. It has 50 protons, apologies, because the atomic number is 50, and it has 69 neutrons because 119, the mass number, subtract the atomic number, which is 50, gives us 69. The next one, F for fluorine. Well, the atomic number is 9, so it has 9 protons. The mass number is 19, and the number of neutrons is the mass number minus the atomic number, so that gives us 10. And finally, aluminium, which is actually the example that we went over in the video earlier. Aluminium has 13 protons and 14 neutrons. Now, this next exercise, what we want you to do is, using the information in the table, which is the mass number, you're going to have to look up the atomic number, and the atomic number you will find on page 4 of the data booklet. So if you look up the name of the element in the periodic table and then find the atomic number, you can put those into the table, and then using the mass number and the atomic number, I want you to work out the number of neutrons. So if you're able to do that, pause the video and have a go at that exercise. Okay, I'm hoping that you've unpaused the video now, and we'll go through the answers. So firstly, I think we'll go through and find the atomic number for each of these elements. So we have helium has an atomic number 2, Fluorine was 9. Strontium was 38. Zirconium was 40. And uranium was 92. So if you were able to identify those, well done. That means you're really good at looking up the periodic table. And now what you needed to do was calculate the number of neutrons. And the calculation to do this is that the number of neutrons is the mass number minus the atomic number. So for helium, 4 minus 2 gives us 2. For fluorine, 19 subtract or minus 9 gives us 10. For strontium, 88 minus 38 gives us 50. For zirconium, 91 minus 40 gives us 51. And for uranium, 238 minus 92 gives us 146. And what we've got here is the last one. For this one, you've been given the mass number, you've given the name of the atom. The first thing you need to do is again use page 4 of the data booklet to find the atomic number for each of those elements. And then what you need to do is work out the number of protons, the number of neutrons, and the number of electrons for each one of those. So if you want to pause the video, get yourself, maybe a calculator might be handy to do this, and the National 5 data booklet and have a go. So hopefully you have unpaused the video now and you've had a go at those questions. Hopefully you've been able to get answers to every single one of those, but if you've just been able to do a couple or just some of the columns, well done. We'll go through the answers now. So the atomic number we get from the periodic table. So boron is an atomic number 5, potassium 19, chromium has a number 24, mercury, the atomic number is 80, and argon, the atomic number is 18. Now what we would look to do is remember that the atomic number equals the number of protons, and the number of protons equals the number of electrons. So from the atomic number, we can write in the number of protons and electrons. And then to work out the number of neutrons, it is mass number minus atomic number. So for boron, it has 5 protons and 5 electrons, because that's the atomic number. And it has 6 neutrons, because 11 minus 5 is 6. For potassium, well, the number of protons and the number of electrons, they both equal the atomic number, so that's 19 for those. And number of neutrons is mass number minus atomic number, which is 39 minus 19, which is 20. For chromium, protons 24, electrons 24, and neutrons 28. For mercury, 80 protons, 80 electrons, and 121 neutrons. And finally for argon, we have 18 protons, 18 electrons, and we have 22 neutrons. So that was a set of exercises on atomic structure and on the different particles inside it. Thank you for your attention. I hope you were able to do all those exercises. If not, you can have another go, and I will catch you next time.